random variable, usually written as x, is a variable whose possible values are numerical outcomes of a random phenomenon. Random variable is a numerical variable whose measured value can change from one replicate of the experiment to another. There are two types of random variable. One is discrete and number two is continuous. Discrete variable. A discrete variable is one which may take on only a countable number of distinct values such as 0, 1, 2, 3, 4, and etc. An examples of discrete variable are number of children in a family, money in your bank account, and number of students in class. Remember that discrete random variable is a random variable with a finite set of real numbers for its range. Last, we're going to discuss of continuous variable. A continuous variable is one which takes an infinite number of possible values. Examples of continuous variable are height, time, and age. Remember that continuous variable is a random variable with an interval either finite or finite of real numbers for its range. Thank you for listening.
Discrete probability distribution. Remember that probability is defined as the ratio between the number of outcomes and the total number of outcomes. Thus, probability is equal to the frequency of variables divided by the total number of outcomes. We're going to use this example where the first variable is the times where the white shirt have shown once. The second one is the frequency where the white shirt have shown twice, and the last is the frequency where it haven't shown. We can now disregard the second column. Now we have the table where x is the variable and p of x is the probability of outcomes. Remember that the probability is the frequency over the total number of outcomes. That's why we've gotten the 1/4, 2/4, and another 1/4. Then we've converted it to its decimal form. Note that we can express this into a fraction or a decimal. Now that we've got the p of x, we can see that all of these are parts of a whole number, which leads us to the first property. P of x is greater than 0 but lesser than 1, or between 0 and 1. If we add this probability of outcomes, we will get a sum of 1, which is the second property of a discrete probability distribution. Summation of p of x is equals to 1.
Okay, so I will be discussing the mean, variance, and the standard deviation of a discrete random variable. So first we have the mean of discrete random variable. We have here the formula, which is the mean equals the sum of random variable x multiplied to the probability of x. So here we have the table. As you can see from the first column, we have here the given values for the random variable x. And on the second column, we have here the given value for the probability of x. And on the third column, here is where you can see the process of multiplying the first and the second column. Okay, so here we have 1 multiplied to 0.1667, which gives us a product of 0.1667 as well. And once you get the product of each values, you just have to add all of it, and that is where you will get the mean. So for this table, our mean is 3.5007, and we attained it by adding this, which is the product. So 0.1667 plus 0.3334 plus 0.50005.001, and so on. So that is where you will get the mean. Now for the variance of the discrete random variable, we have two values with this. So the second value is just an alternative, and for me, I think the easiest way to solve the variance. Okay, but let's focus first on the first formula. So as you can see, the same table from the mean is still here, and this will serve as our guide in solving the variance. So here, now let's look on the step 2. We just have to subtract the mean from the random variable x. So here we have 1 minus 3.5007, and that gives us a difference of negative 2.5007. So the 3.5007 was our mean earlier. Now let's move on to the step 3. We just have to get the squared value of the difference on the step 2 column. So here we have to get the squared value of the negative 2.5007, which gives us 6.2535. Now for the step 4, we just have to multiply the answers on the step 3 to the probability of x. So here we have the 6.2535 multiplied to 0.1667, which is the probability of x, and that gives us a product of 1.0425. Now, once you get all the products again for each of the values, you just have to add all of it, and that is where you will get the variance. So for this table, we have added the 1.0425 plus 0.3754, 0.0418, 0.0416, 0.3747, and 1.0413, and that sums to 2.9173. Okay. Now let's move on to the second formula, which is this one. So this is what I'm talking about earlier, which is, I think, the easiest way to solve the variance. So here we have the same table again from the mean, and we only have the step 3. So here on the third column, as you can see, we have to get the squared value of the random variable x. So here we have the 1 squared, which gives us 1. And then here we have the x squared times the probability of x. So we just have to multiply the third column from the second column. Okay, so let's use the second one. It's the second row. So here we have 2 times 2 equals 4. Then we have to multiply the 4 to the probability of x, which gives us a product of 0.6668. And then same process goes again. We just have to add all of this. Then once you get the sum of these values, of these products rather, we have to get the squared value of the mean. So our mean earlier was 3.5007, and it gives us the squared value, which is the 12.2549. Now we have to subtract the sum of these products to the squared value of the mean. So that will give us the 15.1697 minus 12.2549. That will give us 2.9148. So that is our variance for the second formula, and I think the answers are pretty close to each other. Okay. Now let's move on to the standard deviation. So this one is very easy. You just have to get the square root of the variance. So let's use the variance from the first formula. So here we have the 2.9173, and we just have to get its square root, which gives us the 1.7080. So that is simply the standard deviation of the variance. That's goes with the second formula as well. So that's it for this tutorial, I guess. Thank you.
What you see in front of you is called a normal curve that resembles a bell. So that's why it's also known as the bell curve or the Gaussian curve. And one of its unique properties is the mean, which I'll show you. If I change it to 2, the center of the normal curve is aligned at 2 here at the x-axis. So I'm going to change it back to 0, and you will see that the center is aligned at 0. So in summary, the mean shows us the center of the normal curve. Also, one of its unique property is called the standard deviation. So as you can see, if I give it a standard deviation of 1.2, the normal curve becomes wider. And if I give it a standard deviation of 0.4, you will see that the curve is now peaked. So in summary, the standard deviation determines the wideness of a normal curve.
Hello, my name is John Andre Ardizon, and I will be teaching you on how to convert normal distribution to standard normal distribution and vice versa. A standard normal distribution is the distribution that occurs when a normal random variable has a mean of 0 and a standard deviation of 1. A standard score, or the z-score, is the normal random variable of a standard normal distribution. A formula of normal to standard is sample space minus mean over the standard deviation. An example of conversion from normal to standard when the given is 98 and mean is 80 and the standard deviation is 8. You will substitute the given and minus 98 to 80 over 8, where you will receive 18 over 8. Now you will divide this two and get a value of 2.25, which will be your z-score. A normal distribution is a probability distribution that is symmetric about the mean, showing that data near the mean are more frequent in occurrence than data far from the mean. The standard to normal formula is the mean plus the standard deviation multiplied by the z-score. Using the example earlier where we got the 2.25 for the z-score and mean for 80, standard deviation for 8. Substituting the values from the formula, having 80 plus 8 times 2.25. We will solve here first the 8 times 2.25, where we'll get 18. We will add it by 80, receiving a value of 98, which was our value earlier. That is all. Thank you.
Hello everyone, today I will be discussing about the areas under a normal curve. The total area under the normal curve is equal to 1. So, how do you use or find a specific area under a normal distribution curve? To find a specific area, you have to find the z-score table to find the area. A z-score table is used to find the percentage of the value on a standard normal distribution. A standard normal table ranges from 0.00 to 0.09 and 0.0 to 3.4. To find the specific area, you have to find the z-score of the data value and use the z-score table to find the area. A z-score table is used to find the percentage of the value on a standard normal distribution. So, for example, I have my value as 1.25.
Good day, I am Marian Berlon and I will be explaining the application of normal distribution. Normal distribution, also called as the Gaussian distribution, is a probability distribution that is symmetric about the mean, showing that data near the mean are more frequent in occurrence than data far from the mean. In graph form, normal distribution will appear as a bell curve. There are many applications of a normal distribution, like heights, measurement error, IQ scores, blood pressure, and many more. In this video, we're going to talk about blood pressure. Change in the prevalence of raised blood pressure could be due to both shifts in the entire distribution of blood pressure and changes in its high blood pressure tail. Systolic blood pressure in healthy adult has a normal distribution with mean 112 mm of mercury and standard deviation of 10 mm of mercury. The mean and the standard deviation changes depending on the pump of the blood of a person. Sometimes it can be high, sometimes it can be low, affecting the percentage.